Hello everybody, welcome to another wonderful foldable video from the amazing, the intrepid, the exciting, the ever wondrous Mr. Reynolds. We're going to go ahead and do the next foldable in this chapter. We're on 8.5. This is exponential growth functions. So go ahead and copy down your table of contents right now. Pause as needed, obviously, throughout the whole thing. Pause, rewind whenever you need to. Okay, writing this down. And then we're going to go ahead and jump to the next blank page and do the goal. Hopefully you already have the foldable. If not, you should get it soon. Here we go, going over to the goal. Okay, our goal today, it says I can graph and write exponential growth functions. I can graph and write exponential growth functions. Okay, so we've been doing a lot of stuff with functions, but one of the things we haven't done, sorry, not functions, exponents. We've been doing a lot of stuff with exponents, but we have yet to do anything with graphing them. So what is it like to graph something that has exponents like this? So that's basically what we're doing today. How can you look at a graph or a table of values and figure out what is a function, what is its function? Or how can you look at the function and then graph it? So we're kind of going to go both ways here. Okay, returning ourselves back to the wonderful world of graphing. Okay, when you have the goal done, go ahead and open up your go to your foldable, going to the front, and we are going to start filling it out together. Okay, so today we're starting here with the parent function for an exponential growth function. So basically this is the generic form of the function that we're seeing here. It says p to the x equals ab to the x, okay? So we remember function notation, so we have x and y, right? X is the input, y is the output. So p right here, normally we'd see like f of x or something else, but p stands for parent function. That means this is the most generic version of the function. But we just know that we're going to be changing what x is, and as we change what x is, it changes what we get out of it. So the input is x, we change x a whole bunch, and we get new y's, and we know that p to the x here stands for y, or the output. There's a couple rules. A can't be 0, so whatever you have for a can't be 0. B has to be greater than 0, and b cannot equal 1. Okay, these are all the different rules we have for exponential growth functions. So there's a couple other things we need to know, and we're going to fill them out here right now. What else do we need to know? Well, the base b is a constant, and that means it's a regular number. It doesn't change. And so the b is the base of the exponent, and it's a constant. Next up, we have the exponent x is the input. So we remember input is the x value. That's the thing that we plug in. That's the thing that we change. When we change the x value, which in this case is the exponent, it changes the y value. So if you were to make an xy table, the x is the input, that's the exponent. And then lastly, the graph is going to make a shape. It's going to rise to the right to form a J. Okay, it's going to kind of look like a J. And we're going to figure that out together here. So write these down. These are the things you need to know about the exponential function. Okay, pause if you need to, but we're going to move on to the next bit. Okay, so here we have a couple of examples of some things that we could do here, okay? So hold on one second. I have to grab one thing. Okay. Okay, so f of x equals 2 to the x. Let's start with that. F of okay. So we're going to start putting in some values here. So we're going to start graphing each of these three things. So we have f of x, we have k of x, and we have m of x. So f of x is 2 to the x. Well, there is an a here, right? A is here, but it's invisible, right? we know that there can always be something that is invisible, that can multiply by anything. We know it's an invisible 1. So we know that our A is 1, our B is 2, and our X is still X. X will always be X, okay? So if we were to plug in a 0 for X, so we have 2 to the 0. We all know that everything to the 0 power, 2 to the 0, is 1. So if we plug in 0 for X, and we would get a 1, our answer would be 1. So we actually have 0, 1. So we're going to plot that right there. Here's 0, 1. Okay, that's our first point. We are doing f of x right now, okay? 0, 1. Now let's go ahead and do 1. So let's plug in a 1 right here. So now we have 2 to the 1 power. Well, we know that 2 to the 1 power is 2. That's a good one, okay? And then let's do 2 to the 2 power. So we're just plugging in 2 to the 2 power, and we know 2 to the 2 power is 4, and so we have 2, 4 right there. So not only are we starting with 0, 1, 2, we're also going to go backwards and do -1 and -2. So if we have a -1, we know that a -1, we would put it in the bottom of the fraction, right? We would have to put it 1 over 2. So actually, if we have -1 over here, it becomes 1/2. So let's go. So if we have -1, we go 1/2. And then if we have a -2 in here, it'd be 1 over 2 to the 2, which is 1 over 4. So we're getting this kind of really small thing here, okay? So we have these, and you can see that it's sort of forming a nice J. So let's go ahead and connect the dots to make this awesome J. And we're going to label this f of x, because that's what we're doing, okay? Awesome. We've graphed the first one. Now let's do the next one, k of x. And we're going to use the same 5 points. We're going to use -2, -1, 0, 1, and 2. Okay? So if I like to start with 0 because that's fun. I start with 0, 0. So 2 to the 0 is 1. 1 times -2 is -2. So there we go, -2. Awesome. Then we plug in a 1. 2 to the 1 is 2. 2 times -2 is -4. So 1, we're going to be at -4. And then if I plug in a 2, 2 to the 2 is 4. 4 times -2 is -8. So then we jump down here to -8. Awesome. Then if we go -1, so -1 times 2 would be 1/2. We know that we put it in the bottom of the fraction, so 1 over 2. 1 over 2, 1/2. 1/2 times -2 is -1. And then if we put in a 2 here, it'd be 1 over 4, because 2 to the 2 is 4, so 1 over 4. And 1/4 times -2 is -1/2. So we kind of have our last little point right here. And look at this, it goes down. So our first one we went up, and the next one we went down. That's interesting. I wonder if you guys can figure out, why do you think this part of the J goes down instead of up? And we're going to label this k of x, so we know which equation it goes to. Any guesses? Why does this one go up and this one go down? Interesting. Well, I'm going to go ahead and spoil it. This has a -a, whereas this has a positive a of +1. Okay? And lastly, we're going to do the last one here. So I'm going to put in 0 here, so 0. 0 to the 2 to the 0 power is 1. 1 times 1/2 is 1/2. So that one we're going to kind of squeeze in the 1/2. Okay, and then if we put in a 1, 2 to the 1 power is 2. 2 times 1/2 is 1. So we're going to put in the 1. Then we plug in a 2 here, so x is 2. 2 to the 2 is 4. 4 times 1/2 is 2. So 2, 2. Okay? And then it's going to get even tighter. If we plug in a -1 here, -1, that's 1/2. 1/2 times 1/2 is 1/4. Even tighter in there. And then -2, that's be 1/4. 1/4 times 1/2 is 1/8, even tighter, barely there. And then if we were to connect it all, it's going to kind of go like that. And we will label it as m of x. Okay, so we'll notice now that this guy is also going up. It kind of fits in with what we thought. This is a positive. This was a positive, so they both go up. Interesting. This one's a negative, so it goes down. But this one looks to be sort of underneath or shallower of a J, a little bit shallower of a J. And I would say the reason is because A is smaller. This A is 1, therefore it's kind of a steeper J. This A is less than 1, so it's kind of a shallower J. So we could say that A is going to tell you how steep or how shallow the J is going to be. Interesting. Okay, there's one other thing you have to know about A. A is a very important number. We know that here A is 1 because it's invisible, but these have different A's. This A is -2, this A is 1/2. What do we need to know about A's? We know that the value of A is the starting amount, and therefore A is the y-intercept. So when you're graphing this, whatever A is, you're going to plot that as your y-intercept. So it's kind of like 0, A. And let's see if that's true. Here our A is 1, and on the graph our A is 1. Here our A is -2, on the graph it's -2. Here our A is 1/2, and on the graph our y-intercept is 1/2. So it's true on all the examples, and in fact it's true all of the time. So whatever your value for A is in your function, that's what your y-intercept is going to be. So whenever you're graphing these exponential growth functions, you always are going to use the 3 points. You're going to use the 3 points. You're going to use -2, -1, 0, 1, 2. You're going to use those. Oops. You're going to use those 5 points as your x value, which is your input. So your inputs are always going to be -2, -1, 0, 1, 2. And then you're going to plug them in for x. And then you're going to figure out what your outputs are by whatever your answer ends up being. And those are your points, x and y. Okay? That's how we graph them. Okay, when you're done with that, go ahead and open it up, and we're going to do the inside. Okay, here we go. Opening it up. Okay, firstly, let's talk about how to do this. So now, we just talked about how do we graph. We see a rule and we graph it. Now let's go backwards. What if we see a graph or a table and write a rule? So that's what I wrote right there. So this, right now, we're talking about how do you do this if you see a graph and then you need to write a rule, okay? So the first part, step 1, you need to find the y-intercept to determine what A is. So in your table or on your graph, you're going to see where's the y-intercept, and that, whatever the y-intercept is, that number represents A in your exponential function. It's interesting because we used to use b as y-intercept on a linear function, but now that we're doing exponential functions, a is the y-intercept. It's kind of an interesting anecdote. Okay, step 2. What's the next thing we do? We are going to find the constant multiplier between output values. We know output is y, so we're going to be looking at the y values and trying to figure out what is the constant multiplier between them, and that is what b is. If you don't know what that means, if you don't know what it means to find the constant multipliers, we're going to do a couple of them right now, or in a little bit, to actually answer that. So first you find a by looking at the y-intercept, then you find b by trying to figure out the multiplier of the y values. And then once you have a and b, then you write your function, write the rule in f of x equals abx form. So you'll write down your a, you'll write down your b, and x is just there. So you'll have f of x equals ab to the x form. Okay, that's how we're going to write our answer. So let's jump into some practice. Okay. So here we see, look at our x's are all the same. So x doesn't really give us any information. Okay, but what it does help us is it helps us find a and b. So first off, we need to find a. So we're going to say, well, what is a? So a equals, well, a is the y-intercept, and so wherever you have a 0 in the x, that's the y-intercept. Okay, that's the y-intercept. So wherever you have 0 in the x, wherever you have the 0 for x, that's your y-intercept. And so in this case, our a is 16. Okay? Now we need to find b. b is the constant multiplier. So when you look at constant multiplier, you're going to want to look at the y's, and you're going to say, okay, what do we do to get from one y to the next? So if I go from 1 to 4, what am I multiplying by? If I go from 4 to 16, what am I multiplying by? From 16 to 64, and from 64 to 256. What am I multiplying by in each situation? Right? So from 1 to 4, I multiply by, well, you probably guessed it by now, 1 to 4 is 4. 4 times 4 is 16, 16 times 4 is 64, 64 times 4 is 256. So yeah, we're multiplying this entire row, we're multiplying it all by 4. That means that b equals 4. Okay? So then we now write our rule. We're going to go f of x equals ab to the x. So I have f of x equals, well, a is 16, b is 4, and I'm going to the x power. I put, because these are regular numbers here, I put the second one in parentheses. That's just so we can tell the difference between 16 and 4. Okay? Hopefully this isn't too difficult. Let's go on to the next one. Once again, right here, this is the y-intercept. Okay? So in this case, our a is going to equal 1. We got to still figure out b, right? So we're going to see what are we multiplying to go on this chart here. Okay? What do I multiply 1/4 by to get 1/2? What do I multiply 1/2 by to get 1? And 1 to get 2, and 2 to get 4? You probably guessed it by now. We are multiplying it by 2. Right? So we now know that b is 2. Whatever we multiply all of the y's by is how we get 2. Okay? So now we write our function. We have f of x equals, well, we know a is 1 and b is 2 and to the x power. Now, is this 1 right here, is this necessary? Do we have to put that 1 in there? Well, no. We don't have to put that 1 in there because invisible ones are invisible ones. They can be invisible or visible. It's whatever you want, but I put the 1 in there just so for consistency's sake. Okay, so this is how you do it. If you're looking at a graph and you want to find the function rule, this is how you do it. If it's a picture, you can just make the table out of the dots you see. Most often, in your assignment today, you're going to see mostly tables. So this is how you'll do it when you see a table. Now let's move on to, what if we're talking about an application problem, like a word problem? How would that work out? Okay, so word problems are a little bit different. So exponential growth models, more specific types of growth models. So here's an exponential growth model. You guys can see it right there. So this is sort of your formula that you're going to use. It's kind of like, you know, talking about money or all these different, the growth of the growth of different things in nature. All of those types of things use this kind of formula. And so initial amount is how much you start with. You have your growth rate, how fast is it growing, right? If it's a percent, you have to take it into a decimal. Usually it'll be a percentage, and you'll have to turn the percentage into a decimal. Time period is how long is it happening. And then you kind of have something called the growth factor. The growth factor is when you add 1 to your growth rate. So growth rate is 1 plus the percentage. Okay, that's how we're doing it. So let's talk about so here, you can see here, we have all of these different things. We can see our formula here and our function. So we're constantly increasing at a certain rate. This right here is a to the t. That means the amount after a certain amount of time, all right? Amount after a certain amount of time, and that's actually probably going to be the answer to your question. So this is or just the final amount, the amount at the end. So that's what we're going to write here. A to the t stands for final amount. Okay, that's at the end of the whole process. How much is there? How much of the amount is there after a certain amount of time? That's the final amount. A, well, we already see that up here. Up here, A is your initial amount, or I'm going to say starting amount. If this is a problem that was dealing with money, they might call it the principal. Okay, so starting amount, or if it was dealing with money, they might call it the principal. And then you have how much is the percentage of an increase. So interest rate for money, interest rate would be for money, or if it was just a percentage growth. That's what you'd have there. Okay, and you're going to always change percent into decimal. Okay. Lastly, T is number of time periods. It could be years. It could be minutes. It just depends. Okay, it could be years, it could be minutes. I'm gonna put dots after that because it could go on. Okay, and then 1 plus the rate, we call that the growth factor. So we're just rewriting a lot of the stuff going on in your, what I gave to you up here. Now we're just kind of writing it out ourselves, or if we're talking about money. Okay, so let's get to this word problem. Okay, pause if you need it. Now let's get on to the word problem. So here, Clara invests $5,000 in an account that pays 6.25 interest per year. Write a function rule that models the amount of money over time. What's her balance after 7 years? Okay, so this gives us everything we need to know. She starts with $5,000. We know that $5,000 is our starting amount, so we're going to say that is A, in terms of this right here, starting amount. Okay, and then interest pays this much interest, 6.25 interest. Well, that's as a percentage. We want to, this is R, right? But we want to turn it into a decimal. So to turn a percentage into decimal, you take the decimal and you go twice to the left. So if I were to bounce this twice to the left, I'd end up with 0.0625. Okay? And it says per year. That means years are going to be our unit of time that we're using. Okay? So now I'm going to write my function. I have all I need. All you really need is R and A to figure out what to write for your function rule. So we know that a to the t, which is the amount after a certain period of time, is equal to A, which is 5,000, times 1 plus the rate, which in this case is 0.0625. And after a certain number of years, and we don't know the years right now, so we're going to put t. So t is right there. Okay? So now you are going to think about, well, what is the balance in the account after 7 years? Well, we know that years is the amount of time, and that's t. So all we have to do is plug in 7 for t, and that's going to give us our value. So we have a, well, we know that t is right here, right? So instead of a to the t, we're going to write a to the 7, because we're talking about what if t was 7. A to the 7 equals 5,000 times 1 plus 0.0625 to the, instead of t, I'm going to write 7. Okay? So now all you have to do is put that amount of things into your calculator. So that's what I'm going to do here, doing it exactly as written. So I'm going to do 5,000. So 5,000. Parentheses 1 plus 0.0625. Close the parentheses to the 7th power. All I did is put it exactly in the calculator as it is on my page. I press enter, and I get this big number. So we're dealing with money. Okay, so the amount is approximately, because we're going to do a little bit of rounding, approximately 7,000, this is money, $7,643, and we'll just call it 15 cents. Okay, that's pretty cool. At 6.25 interest after 7 years, she's gained, $2,643 basically. So that's how much money is left over. That's how much money you have in your account after you let the interest grow for you. That's pretty cool. Okay, that's it for this foldable. Ladies and gentlemen, you have an assignment. I wanted to show you a couple things in the assignment. So you can pause it here, get your books out, get ready to go on the assignment, and I want to show you a couple things. Okay. So I have here some graphing. I want to sort of talk about a little bit about graphing. So in your assignment, you have 4 through 12, which is right here. And then the first 4 problems are all about what is the rule. We already talked about in your IMJ. And then you have 4 problems here, 9 through 12, which are graphing. And then you have 22 through 25, which are graphing. So you'll notice that 4 through 12, the A is always 1. And then the 22 through 25, the A is different things. So that's what I'm going to do. I'm actually just going to do real quick. I'm actually going to do number 22, y equals 2 times 3 to the x. So that's number 22. Okay, number 22, y equals 2 times 3 to the x. Well, this is pretty simple. We know that A is the y-intercept, which is right there. So I plot it right there. Yeah, we'll do that. And then then I start plugging in. I know I'm going to plug in -2, -1, 0, 1, 2. So -1 would make this 1/3. 1/3 times 2. My calculator went away. 1/3 times 2 is 2/3, I think. 1/3 times 2. Yeah, it's 2/3. So then, so if I have -1, that makes that 1/3. 1/3 times 2 is 2/3, which I'll put right here. And then 1/9 times 2, because if I make this -2, that makes it 1/3 to the 2, which is 1/9, 1/9. 1/9 times 2 is 2/9, which is even smaller in this area. Then I start making this a 1. 3 times 6, that is 6. So 1, 2, 3, 4, 5, 6. That kind of brings us here. And so we know that the last one is going to be way off the grid. It'll be huge. It'll be way high. So I'm just going to stop there. We're not going to do +2. And you just go ahead and graph your line. That's all it is. You just plug in your x's. If you wanted to make a table out of it, you're more than welcome to do that with your x that you're choosing and your y. So you can go -2, -1, 0, 1, 2. So this I knew was 1/9. 1/3, 3, etc. Okay? No, not 3. 2, and this is 2/3. Gosh dang it. So 2/3, 1/9, 2/9, 2/9, 2/3, 2, 6, and then we didn't do this one. Okay? Anyway, and then so if you make your table like this, you can just plot all 4 of those points over here, and you're good to go. Okay? That's how you graph it in the real world. Thanks, guys. Appreciate you watching. See you later. See you on Wednesday. Goodbye.